This video is about how to solve a so-called square roots puzzle programmatically. In these puzzles you have a grid into which you have to fit words. Typically the published puzzles have a 5x5 grid such as this. Now some of the squares will have asterisks in them. And these indicate where vowels have to go in the puzzle. Other squares are shaded, and this means these are squares into which the start of which the word has to start in, and then you have a list of words that you have to fill into the grid. Now these I find to be fiendishly difficult to do, these puzzles, and there are literally billions of ways you could fit the words in. So how did I go about writing a program to solve the puzzle? My solver just uses very simple programmatic techniques. Obviously there's a bit more to creating the front end and doing various checks, but fundamentally it just uses for loops and if statements. So a for loop repeats a series of commands for different values of a variable. So you might say for I equals 1 to 10, for example. So the variable I is iterated through the values 1 to 10, and everything within that loop is then evaluated for each of those values of I. Then the if statement obviously is just testing the value of the variable. So you might say if I equals 3, then do something else, do something else. So how do I implement these simple programmatic commands to solve the puzzle? Well, you might have typically 6 to 8 words in the puzzle. So firstly I need to know how they can fit into the grid. So I iterate over the words with a for loop for word number equals 1 to number of words in the puzzle. And for each of these words I iterate over the starting cells, these shaded cells in the puzzle. So I might call those 1 to 4 in this case. More than one word can start in any of these starting cells, or it might just be a single word that starts in it. So I might be looking at the first word and the first starting cell here. So I say the first check to do is, can the word fit in this starting cell? So has it got a star to indicate a vowel? So if the word starts with a vowel but it's not marked as a vowel, that starting cell, then it can't start there. In this case none of the starting cells are vowels, so our word would definitely not start with a vowel, or it couldn't fit into the puzzle. So that's the first check I do, is if the starting cell is a vowel or not. From there I then do another for loop over all the remaining letters in the word. So for letter number equals 2 to the length of the word, because we've already looked at the first letter in the word. And then I do another for loop over the directions I could move from each cell to another. So there's 4 directions, there's up, right, down and left. So I'm looking at the first word, the first starting position, and the first direction I can move is up. Well, the first test I then do is it still on the grid? In this case obviously it isn't. But if I move right, it is still on the grid. So then I can do some further tests on that second letter in the word. Again I can see, is it a vowel or not? So that cell hasn't got a star in, so that can't be a vowel. I then look and see, is that another starting cell, which it isn't, but if it was, I could say the letter that goes in there, the second letter in the word, would also have to be the first letter of a word, or that letter couldn't be in a starting cell. And then the final test I do is, has the letter already been used in the word I'm looking at for the arrangement of letters I'm looking at the moment. So in the second letter that's not going to happen, but if I was say on the 6th letter of the word, I might have come back to the cell I'd used earlier. And in that case, if a word crosses over itself, the second or subsequent time it uses that cell, it's got to be trying to put the same letter in as it used earlier. So I assemble this grid. I do that all those loops over each word in the puzzle, each starting cell in the puzzle, each direction from letter to letter, and I make a whole list of every way in which the words could fit into the puzzle. Generally, you'll find there are a lot of different ways that some words can go into the puzzle. So some words, if you're lucky, you'll find will only go in a couple of different ways, but other words you'll find literally go in 40 or 50 ways into the grid. The next stage in solving the puzzle is to find a combination of all these word positions that work together as a whole so they can all fit into the grid at once without any conflicts. So I need to compare each position for each word with each position of all the other words until I find a solution that works. So I start off with comparing position 1 for every word and trying to put each word into the grid in turn until something clashes with something that's already in the grid. So if I'm looking at all the position 1s, I might get to word number 7 and it will try and use a cell that's already used but trying to put another letter into it. So in that case I have to abandon that solution and look at a different position for that word 7. Hopefully I'll find a solution that works, which gets all the words in, and then the final test I do is to check that all the cells have been used in that puzzle, that there aren't any empty cells. Now the total number of combinations of ways in which the words will fit you get by looking at the number of ways a given word will fit into the puzzle and then multiply those together for all the words. So if word 1 fits in 50 ways, then you multiply by that by the number of ways word 2 will fit, which might be 12 ways. Multiply that by the number of ways word 3 will fit, which might be 18 ways, etc., etc. So for a typical puzzle with 7 words maybe, and a typical number of ways they'll fit into the grid, you will get billions of combinations, ranging from the low billions to hundreds of billion, depending on how difficult the puzzle is. And it turns out this takes a very long time to solve, even on a computer. You're talking hours or days to solve the puzzle, so that's not great. So I then started to think about how many of the word positions I could get rid of using some simple tests. So the first thing I thought is if a word can only fit into one starting square, so you can look through all your positions for a word, do they all use the same starting square? If they do, it means no other word can start in that starting square unless it starts with the same letter. So that allows you to throw away some word positions. And the second test I thought of doing was, does putting a word into the grid in a certain way block any other word from fitting anywhere in the grid? So when I'm looking at a word, the layout of a word, I then look at all the other words. Could they still fit around that in some way? Or does it rule out all positions for that other word? And if it rules out all positions for any of the other words, then this positioning of the first word can't work. So I can get rid of that as well. Well, doing that typically sort of got rid of some puzzles. It got rid of a lot of solutions, say 80%, but some it was only getting rid of 20% of the solutions for the positions of the word. The other thing I thought of doing was ordering the words in terms of the number of ways they could fit into the grid. And I found that if I ordered the words so the ones that could fit into the grid in the least different ways were put first in the list, then this speeded up the solution time when it was going through that final combination of all the word positions, seeing if they're compatible with each other. Ordering the words from the least different positions to the most different positions speeded up the solution time. It about halved the solution time. But still on difficult puzzles I was getting solution times of hours or days. Simple puzzles it would solve in a few seconds. On the face of it, it's difficult to see which are easy puzzles and which are difficult puzzles, but it does depend on things like whether all the words start with a consonant, so that increases the number of options. Then I hit on a breakthrough to speed the process up, so any puzzle can be solved in seconds or under a second in most cases. And this was because when I'm trying to fit all my words into the grid to find an overall solution, I found I was doing something a bit silly. Because I don't know how many words are in the grid, I'd used something called a recursive function call. So rather than having for word number 1 equals 1 to the number of words, and then another loop inside that saying for word number 2 equals 1 to the number of words, because I didn't know how many words were in the puzzle, I created a function and then I called it from within that function for the next word in the list. And I realised that when I was finding a solution that didn't fit, so as soon as something hit something in an incompatible way, when I was putting the puzzles in, I was abandoning that attempt at a solution. Say word 3 position 3 was clashing with something, I was going back and retesting it and trying to test it with the next position of word 4 and 5 and 6. Whereas I could just say that word 3 position 3 doesn't work, so I need to move on to word 3 position 4. And it's a bit difficult to get your head around when you've got these recursive loops, how to exit out of one of the levels of the loop. Because normally you would put an exit 4 inside the loop you wanted to exit from. But when you've got a recursive loop, you haven't got all your for statements nested inside each other like you normally do. You've just got one function. So you have to keep track of what level you're at and what position you're testing for each level. So I can then do an exit 4, but I can also generally in the thing say that if the level I'm looking at or the word I'm looking at is higher than the number that's failed, then I can exit that 4 as well. And that just did massively speed up the solution. So this is what the solver looks like. I started off writing in Excel with Visual Basic for applications code, but I don't really like doing things in Excel in that way, and I wrote it in a very old version 5 of a standalone Visual Basic. The code behind it is pretty much identical to the code I wrote in Visual Basic for applications. I just copied it over. The only difference is the way it interacts with the input object. So here we've got text boxes within the Visual Basic form, whereas in the Excel version I had Excel cells, and the way in which you refer to the two objects is different. So in my solver I have a grid here which you type in the vowels as asterisks, a grid here where you mark the starting squares as crosses, a grid here which is used for outputs and also any guesses you want to make that you want to check. Here you've got your words lists down in the middle of the screen. You can also resize the grid so it'll solve any puzzle that's from 2 by 2 cells to 10 by 10 cells. So the first thing you do is you count the word positions, and as I said, for one of my earlier speed up attempts, it will reorder the words into the ones which fit into the grid in the least different ways. So here ape will only fit into the grid 4 different ways, whereas Mangabe will fit in 59 different ways, the number in brackets there. The smaller numbers here, so 49, are after I've done my pre-culling, depending on whether it was blocking all other solutions or not. So that reduces the number of solutions, but still you've got to multiply all these numbers together to give you the total number of solutions. So I now click Solve Puzzle, and you can see it's pretty much instant, whereas earlier when it was taking hours to iterate through all the unnecessary combinations, this progress bar was moving very slowly indeed, and the options So there was a lot of writing stuff I did which I don't really need now. It solves anything instantly. Now this is just a puzzle I made up, and it's interesting to see that it says it has 3 solutions. So once I find one solution, I don't generally stop unless I've got this find single solution ticked. It will go on to see if there are any more solutions. And a genuine puzzle should only have one solution. So it's saying we've got 3 solutions for this puzzle. There's various things I can do once I've solved the puzzle. I can just reveal the whole thing by clicking reveal all, because I've got 3 different solutions. I have to type in which solution I want. So that comes out in this top right grid. You can see with the starting squares marked. I can clear the output grid. Another thing I can do is reveal a specific word. So say I wanted to see how lemur fitted in. I could type 4 in the word to reveal specific word. So I want solution number 1, and it will show me lemur fits like that. I can also check any hunches I have. So when you're trying to solve a puzzle by hand, you'll often think, oh, I'm pretty sure that word starts in that cell. And quite often you're wrong. So it's quite useful to be able to check if you've got a strong hunch about something. So I might think, right, I think that's an L. So I type an L in there. Or I might think this is a P down here. Or I might think, well, I'm really stuck. I really want to know what this cell is. So I type a question mark in there. And then I do check entries and reveal question marks. Again, because it's got 3 solutions, I have to choose a solution. And then it colours the cells where you've entered a letter. It will say my L guess is right. My P guess is wrong. So it's marked in red. My L guess is right, so it's marked in green. And my question mark square, it tells me it is an A, and it marks that in yellow, meaning it's revealed it to me. So the P, it doesn't replace with the right letter, it just tells me it's wrong. A few other options here, so I can save a puzzle, just brings a standard Windows save box up, or I can reload a puzzle. This one's got a different number of cells, I know. It was one from testing. So this is a 2x2 grid to show you. And so I can load a puzzle as well. I can, if it's solved, then it won't let me change any inputs until I do unlock inputs or clear all. I can resize the grid. I haven't shown you that yet. So if I wanted to do a 10x10 puzzle, which would be absolutely fiendish, I can resize grid, and then it gives me a 10x10 grid to work in. So I think that's about it. And in the description of this video, it will show you where you can download this Visual Basic program, including the source code, which is probably horrendously written, but it does seem to work. So thanks for watching.